Hello students, please let me know if you are here and if I am audible or not. So yeah, I am just 3 minutes late in today's class. Please check if I am audible or not. So today I am going to discuss a very important chapter, that is current electricity. It is important for not only for your PU board, it is also important for your class test as well. Yes, Shifa Kausar, it is started. As I said, I am 3 minutes late. Sorry for that. Good evening Aryan. Good evening Varija. Good evening Shifa. So very important chapter, current electricity, and questions are some questions are very easy, some questions are little critical, so you have to think twice before answering. So let's start with the first question. First few questions I have kept intentionally easy because some students generally join a slightly later part of the lecture. So first question, let's start. Yes, so very easy question. What is the SI unit of current? So can I get some answer? Hi Aman, good evening. Please, the rule for answering is you have to mention the question number. First you have to mention the question number, then you have to mention the correct answer. So suppose correct answer is 1A, so you have to mention 1, then you have to mention 1A, like that, or 1A. Whatever you feel, whatever is easier for you, you can answer it. Aman said good evening, then he answered A, then he deleted the option answer, right? Anyway, Shifa is saying 1A. Charge of what is the SI unit of electric current? Read the question carefully. Aman is now answering, Pooja is now answering correctly. Shifa, unfortunately, yes, now you have also answered correctly. Pooja, 2B is not. First you have to answer first question. Okay, yes, 1B, yes, 1B, that is ampere is the correct charge. So ampere is the charge for correct unit for current. Coulomb is the unit for charge, right? So now next question, let's move on to the next question. Read the question. When no current is passed through a conductor, the free electrons do not move. The average speed of free electrons over a large period of time is not 0. Very important. Okay, the average velocity of the free electrons over a large period of time is 0. The average time, average of the velocities of all free electrons at an instant is non-zero. So obviously you can see that from the options it is clear it will be either B or C. Okay, because these two statements are almost same, only the difference is in the whether it will be 0 or it will be not 0. Okay, other than that, this is a complete different statement, this is also complete different statement. Electrons are always moving, you can consider that electron gas. Shifa is saying to C. Anyone else, please response. Pooja, to C. Aman, what happened to Varija? Sandhini is asking, hi, please provide the PDF of 90-day strategy plan with dates and lesson. Yes, Sannidhi, we will try to provide it. Monday you will get that. Okay, Monday definitely I will provide. I will ask other teachers also provide the 90-day strategy with dates, everything. Okay, we will provide that, don't worry. Now, so question here it is, for average velocity of free electrons over a large period of time is 0. That is why if no electric current is passing, that means average velocity of electrons are 0 over a large period of time. So that is basically the statement is easy, but they have complicated it slightly so that you face difficulty. Now question number 3, another interesting question. In the absence of an electric field, the mean velocity of free electrons in a conductor at absolute temperature T. Absolute temperature T means in Kelvin scale basically. So temperature T is constant. Basically they have given the temperature absence of electric field means no electric field is applied. That means no electric field means current is also 0. Absence of electric field means current is 0. Now what is the mean velocity of free electrons? So same question as previously, only thing is the language is changed, the way it is represented is changed. Now please any answer for third question, easy question, same as the last one, only thing is they have changed the perspective, right? Anyone? So as I have discussed that it is 0, for average speed is 0, so it will be, answer will be 0. So no electric field means current is 0, current 0 means either you are answering it late or I am not getting your answer, please respond, otherwise the class will be over very quickly, right? The class, I am live here because of you, after all of your demand. Ohm's law is valid when the temperature of the conductor is. So another easy question, Ohm's law is valid when temperature of the conductor is very low, very high, constant, varying. So Ohm's law is only valid, that is the statement of the Ohm's law, when temperature and other physical constant remains same, the current is directly proportional to voltage, right? So we know that from the fact it is constant. So anyone is answering, please reply, because I am not getting any update over your chat, even though I can see. Yes, now I am seeing the answer. Pooja is saying 3A, Aman Shetty 3A, Pooja 4A, Aman Shetty 4C. 4C, yes, 4C. Aman Shetty, you are correct. So Aman Shetty, you are correct. Pooja, unfortunately, it is not A, it is constant. When temperature is constant, then only Ohm's law is valid. Okay, at very high temperature, definitely Ohm's law completely fails. Okay, at very high temperature, but normal temperature, if the temperature is constant, then Ohm's law is valid. Okay, so not very low temperature, normal average room temperature is fine. Only thing is temperature has to be constant. Okay, now next question. So in the equation AB equals to C, now this is a, from here on we are going towards slowly towards some critical thinking questions. To answer this question, you have to use your pen and paper, or you have to be very smart. So the in the equation AB equals to C, A is current density. So A is current density, that is J. Okay, C is the electric field. So C is the electric field, that is E. Then B is resistivity, conductivity, resistance, potential difference. Resistivity is denoted by the symbol rho, conductivity is denoted by the symbol sigma, resistance is denoted by the symbol R, potential difference is V. Now these are not given in the question, I am giving you so that you can answer this question without any trouble. So let's see who answers this question correctly. Pooja is saying 5B. Okay, so this is like a, so if you are playing KBC, this is like a 1 crore question. Okay, so this is will be the one of the biggest question of the chapter. So if you answer it correctly, you will get 1 crore, like that. So this level of question, this level of difficulty. So not simple, if you have to think before answering. Okay, let me restart this once more. I am not getting any update from you guys. So update is coming, but it is coming late. So let me restart the I hope now I can see your So what is AB? A is current density, so J. Okay, B we do not know, J into B equals to E, right? So J into B equals to E. Now we know that one equation, J equals to sigma E, right? So J equals to sigma E is the other form of Ohm's law. So here as you can see, J is with another term where E is alone. So first we have to make E alone. So E is basically equals to J divided by sigma, right? So E equals to J divided by sigma. Now 1 by sigma, that is 1 by conductivity, is nothing but resistivity, right? So E is basically equals to rho J, or rho J equals to E. So this is the equation that is given to you. So this is the equation that is given to you smartly. So this is a higher order thinking skill question. So the correct answer is option A, not option B. Okay, Shifa, Pooja, you are all incorrect unfortunately. So correct answer is resistivity, even though the common tempting option is conductivity. If you solve such questions without thinking, without writing the values, then you will definitely go wrong. This is a question where students miss out, and this is a very common type of questions coming in your PU board exam. This type of question, not exactly this question will come, but this type of question will come in your PU board exam, and you will struggle if you don't know how to answer this question. You have to solve it step by step. We know this is known equation, J is equal to sigma E. From there you have to separate E, because in the given example it is given that E is alone. So you have to make E alone, and then you have to identify that 1 by sigma is basically rho, right? So from there you can say, okay, this will be the resistivity rho, not conductivity R. Now 6th question, which of the following is non-ohmic resistance? Easy question. So I will wait for few seconds. Lamp filament, copper wire, carbon resistor, diode. Okay, so please answer it quickly. D. Pooja is saying 6D. Mr. Artist joined late. So Mr. Artist is also saying D. Yes, diode is a semiconductor. Rest of them are conductors, so they obey Ohm's law. Only diode does not obey Ohm's law. So basically, the correct answer for this question is D. Okay, let me arrange this quickly. BJ is also saying D. Yes, Shifa, hi Shaukat Ali. Shaukat Ali is also joined. Pooja, everyone is saying D. So this is an easy question. Option D is the correct answer. Now question number 7, another interesting question. Please quickly answer it. The relaxation time in conductors, relaxation time is denoted by symbol tau. Okay, increases with the increase of temperature, decreases with the increase of temperature, is independent of temperature, all of sudden changes at 400 K. This is also an interesting question. If you don't know it, you will not be able to answer this question. Okay, I can give you one hint that relaxation time is inversely proportional to resistivity. Okay, resistivity and relaxation time, they are inversely proportional. There is an equation. We will see that equation in a while. We have a question for that, but for now you have to remember that relaxation time and resistivity are inversely proportional. Now I hope that will helpful. Please mention the question number, BJs and Sachin. So whenever you are answering the question, because it is not instantaneous, you might be seeing this video and answering it immediately, but I have to wait for 10 seconds. So by the time maybe I have moved on to the next question. So please mention the question number. Aishwarya also. Aishwarya, Sachin, BJ, please mention the question number like Pooja, Aman and Shankar is doing. Okay. So correct answer is decreases with the increase in temperature. Yes, correct answer is option B, because rho increases with temperature, right? As we increase the temperature, the resistivity increases. So definitely relaxation time will be inversely proportional to the temperature. So, as we are increasing the temperature, the relaxation time will definitely decrease. Correct. So, all of you are correct. Option B is the correct answer. Now, next question, question number 8. With the increase in temperature, the conductivity of, so another interesting question, semiconductors increases and metals decreases. Metals increases, semiconductor decreases. Conductivity, remember that this is conductivity, not resistivity, very important. So, we have seen similar questions, but in a different way, where resistivity was asked, but now here we are asked with conductivity. So, very careful while reading the question, you have to guess the answer. Semiconductors increases, metals decreases, metals increases and that of semiconductor decreases. Both metals and semiconductors increases, both metals and semiconductors decreases. Now, we know that conductivity, be it resistivity, it is different for semiconductors and conductors. So, definitely these two options are not correct. Okay, they cannot have the same thing at the same time. So, definitely it is again 50-50 question. So, either option A or option B. Now, Pooja 8A, Shaukat Ali Tehsildar 8A, Aman Shetty 8A, Shankar 8A. Hi Varija, you came and then you left. Varija also joined in. Aishwarya 8A. Yes, 8A is the correct answer. Correct. So, semiconductor, as we increase the temperature, semiconductor becomes better conductors, whereas metals become less good conductor. That means conductivity of semiconductor increases and that of metal decreases, as simple as that. Now, drift velocity, now we have moved into drift velocity, very critical thing. When I was a student, it was very difficult for me to understand drift velocity, but slowly I have moved on. So, drift velocity of electrons is due to motion of conduction electrons due to random collisions, motion of conduction electrons due to electric field E, repulsion to the conduction electron due to inner electrons of ions, collision of conduction electrons with each other. Now, the question is very straightforward and only one of the answer is correct. So, there is no other incorrect option. Yes, I can still I can see some students already answered it. So, Varija saying 9B, Shankar saying 9B, Aman also coming in with 9B. Yes, motion of conduction electrons due to electric field E. Yes. So, whenever you apply electric field, the electrons slowly starts drifting in the opposite direction of the applied electric field, right. So, if you apply electric field, electrons start drifting in the opposite direction of the electric field. That is why it is called drift velocity. Slowly it is moving. Question number 10. Constantan wire is used for making standard resistance because it has, this is a old question, but common question. So, Constantan wire is used for making standard resistance because it has high melting point, low specific resistance, high specific resistance, negligible temperature coefficient of resistance. Now, again options are self-explanatory and easy to answer. Varija is yes, Varija. Sanjana, we joined, Sanjana answering 9B, yes, 9B was correct answer. Pooja was also said 9B. Shankar saying 10D, Aman 10D, anyone, I will take one more answer. Even nichrome and manganese, yes, Varija, yes, you are correct. Sanjana, you are also correct. 10D, negligible temperature coefficient of resistance. So, their resistance varies very small with respect to the temperature. So, even if the conductor becomes very high, the temperature becomes very high, their resistance change is very negligible. That is why it is important to make standard resistance. Standard resistance means whose resistance does not change with temperature, right. That is why manganese, constantan and nichrome, they are preferred as standard resistance. Yes. Okay. Now, let's move on to the question number 11. Another important question, the resistivity of metal wire. So, resistivity means obviously rho. Now, in the previous question, just want to elaborate slightly that specific resistance may be a new term to you, but specific resistance is nothing but resistivity rho. Okay, they are same thing. So, in future, in case if you see this term specific resistance in any question, you have to remember this is nothing but resistivity rho, that is a separate name for the same term. Okay. So, resistivity again specific resistance. Okay. So, the resistivity of a metal wire increases with the length of the wire, decreases with the area of cross section, decreases with the length and increases with the cross section of the wire, increases with the temperature. Now, tell me which is the correct answer. Tricky question. Shagufta joined 10D, Aishwarya 10D, Aishwarya answered 11D. Okay, anyone else? Shankar saying 11D. I will not reveal the answer. This is interesting question. That's why I will wait. Even if maybe it's correct, obviously. Shagupta 11D. Anyone else? I will take two more answers. Shaukat Ali 11D, Aman Shetty 11D, Sanjana 11C. No, not 11C. 11C is not correct. I was expecting at least someone will answer 11C. So that's why I was waiting. Correct answer is 11D. Now, why 11D? Because resistance is rho L by A. So, resistance directly proportional to length, inversely proportional to area. So, instead of resistivity, if the same question was asked with resistance, then this one would have been the correct answer, and D also. Okay. But resistivity is constant for a given metal at a constant temperature. Resistivity changes only with temperature for a given metal. So, for a given metal resistivity, if the temperature is constant, resistivity remains constant. This is a constant for metal, right. So, for iron, whatever the resistivity of iron, say at 20 degrees Celsius, that resistivity of iron of 20 degrees Celsius will be constant even if you test in India, if you test in US, you test in UK, everywhere across the world. Even if you go to space and test it, you will find the same resistivity as long as the temperature is constant. Okay. But if you are testing for say iron and copper, resistivity will be different. So, resistivity changes with material, resistivity changes with temperature. These two are the only things that can make a resistivity change. Resistance on the other hand depends on length, depends on area, etc. Okay. Clear? Sanjana? Yes. Yes, relaxation time, in a sense relaxation time depends on temperature. So, that is why you cannot directly say relaxation time. So, relaxation time depends on temperature. So, there is a inversely proportional to, you can fix the relationship between resistivity and relaxation time. So, resistivity is inversely proportional to relaxation time, yes, but they are actually linked with temperature. Okay. So, temperature, if you add the temperature term, the relaxation time will go away. Okay. Thank you. Yes, 12B already started answering. Sanjana V, Shankar is saying 12B, Varija is saying 12A. So, let me Shagupta 12A, Aishwarya 12A. So, in n identical cells of each EMF, E and internal resistance R are connected in series and external resistance R is connected in series. With this combination, the current through R is yes. So, there is a one external resistance capital R. Now, so there are n cells of each EMF E and each having internal resistances small r. So, I am drawing the equivalent circuit say. So, total, what is the total EMF? Total EMF in series is basically multiplication of NE. So, this is the total EMF divided by total resistance, that is the current, right. So, total resistance is basically R plus the total resistance of the all cells. So, total resistance, they are in series, simply you can add them, and if you add n times it is n multiplier, right. So, I gave you one example, R plus R is 2R, right. Similarly, if you R plus R, it is 3R. So, if you add R twice, you get 2R. If you add R thrice, you get 3R. So, if you add R n number of times, then you will get NR, right. So, many students get confused why it is NR. Okay, if you are just adding the n times, you get NR, right. So, it is R plus NR. So, NR is the equivalent resistance. NE is the equivalent EMF. So current is NE by R plus NR. So correct answer is option A. So those who said, Pooja says option A, Aman also A, Shaukat Ali option A, Varija for parallel. Yes, parallel is slightly tricky. Yes, for this case is E plus R plus N by R. Yes, correct. If they are saying yes, Sanjana is 12A. So all of them have answered it correctly. So this is slightly easier question because it is parallel. Maybe parallel is slightly tricky for your PU board, but it is very it will be considered as an easy question for your KSET exam. So there is a boundary between this, but series 1 is higher order question for PU board. Okay. Now question number 13, if the terminals of a cell okay. So if the terminals of a cell are connected to an external resistance, then the potential difference across is terminals. This is a understanding based question. So we have a resistance, we have a cell. Cell means definitely a cell will obviously have an internal resistance. Now the terminal voltage, what is the relationship between this V and epsilon? Okay. So more than EMF of the cell. So terminal voltage is more than EMF of the cell, less than EMF of the cell. So V is less than EMF of the cell, equal to EMF of the cell. So V is equal to epsilon, or equal to potential drop across its internal resistance. So across internal resistance, whatever is this, say small v. So this is capital V, by the way, this is small v. So it is basically small v equals to epsilon. So these are the 4 options. So from this already Sanjana 13B, Shagufta 13B, Shankar 13B, Varija 13B, Shaukat Ali 13B. Yes, less than EMF of the cell. So because there is an internal resistance, some voltage drop small v will occur across this internal resistance. That's why the terminal voltage will be epsilon minus this small v. Now if you know the current in the circuit, if you know the current in the circuit, say I, if the current in the circuit is I, then the voltage drop across this small r according to Ohm's law is I into R, that is epsilon minus IR. So this is the formula that you have to remember. Okay. Now based on this we can say that V is always less than epsilon, does not matter. Okay. Maximum max to max, if it is an ideal cell having 0 internal resistance, then it can have V is equals to epsilon. So if the same question was asked with an ideal cell, then it will be V equals to epsilon. Otherwise it will always less than epsilon. Now ideal cell is not possible, so obviously it will be less than epsilon. Next question, Kirchhoff's first law, that is sum of current equals to 0 at a junction, deals with the conservation of. So now Kirchhoff's first law, that is all current entering a junction is 0, deals with the conservation of. I have discussed it multiple times, a lot of times. Okay. So we know that whatever is the incoming current at a junction, that is the junction rule. So suppose I1 and I2 are entering, whereas I3 and I4 are exiting, then Kirchhoff's junction rule says I1 plus I2 equals to I3 minus I4 plus I4. Okay. Or in the other hand you can say I1 plus I2 minus I3 minus I4 is equal to 0. This is basically sum of I equals to 0, right. So for entering the junction it is positive, exiting the junction it is negative. That is how it is come to be summation of I equals to 0. 14C, KVL. Yes, KVL is conservation of energy, and KCL, that is Kirchhoff's current law or Kirchhoff's junction rule, is conservation of charge, that is 12C, 14C, right. So KVL is conservation of energy, KCL is conservation of charge. Both things are coming from two very common conservation. Now this is a very interesting question. Okay, in the experiment of Wheatstone bridge, the positions of cell and the galvanometer are interchanged. Then the balance point will change, remain unchanged, depends on internal resistance of the cell and the resistance of the galvanometer. None of this. Very interesting question, higher order thinking skill question. So we have a Wheatstone bridge. So here we generally attach the galvanometer and the cell is connected like this, right? This is the circuit for Wheatstone bridge, right? Now they are saying that in the question it is said that you have interchanged the galvanometer and the cell. So basically now what is happening, you have fixed the electric cell over here and the galvanometer is connected over here. Okay. Now what will happen to this condition for balance? Now I am helping you to redraw this circuit. You can redraw this circuit by saying that okay, I already know what is the points. So now voltmeter, galvanometer is connected like this and the cell is now connected like this. Now this is more familiar to us. This diagram is more familiar to us. Now tell me the answer. 15A, 15A, Sanjana saying 15B. Shagupta saying 15B, Varija saying 15A. Actual correct, Shankar is also saying 15B. Correct answer is remain unchanged, 15B. All those who answered 15B, clap for you. So this is actually a very interesting question. It will not change because what is the condition for balance? P by Q is equal to R by S, right? So P by Q equals to R by S. P by Q equals to R by S, right? This is the condition for balance. Now if you see, this is P now, this is Q, this is R, this is S. Now let's see what is the condition for balance in this case. Okay, if you see in this case the balance will be Q by S is equal to P by R in case if they are in balance. Now can you rearrange them to the same condition? Just do the reverse calculation. Okay, so just exchange this Q and R. So you will say P by Q equals to R by S. So if you see that in this case also the condition of balance remains the same. So always remember that if there is a galvanometer over here, okay, so the arms which are directly connected to galvanometer, this by this equals to this by this. Now in this case, this by this equals to this by this. So if you solve it, you will see the same condition is still valid. So no matter, even if hi Kannadiga, so you have missed a very important question, very interesting question that we have solved, right? And you are every day after half of the class is almost over, you are joining. Anyway, welcome to the class. So P by Q is equal to R by S remains unchanged. That's why the condition of balance will remain unchanged. So it does not matter how the galvanometer or how the battery is arranged, the condition for balance will remain unchanged. Thank you those who answered correctly. Now next question, question number 16. This is a little difficult, tricky question. I will give you 2 minutes to answer this question. So basically it's a matching question. So there are few quantities. One thing that I have to correct is these numberings are wrong. Okay, these numberings are wrong. This is say I need to check the options also, but if everything is correct, this will be the options. So 3, this will be the 4. Okay, I have not checked this answer if it is matching with any of the options or not, but anyway, question is very interesting. I am giving you 2 minutes to figure it out one by one. Now relaxation time is easy. Okay, relaxation time is easy. Drift velocity may be slightly tricky. Current density is easy. Electrical resistivity also easy. So, drift velocity, if you leave drift velocity, first try to find these three terms, what is the relationship, then based on that we can find. So, Varija saying 16b, Shankar saying 16a, Shagufta saying 16b. Try to calculate it, then find it. Okay. Now, I told you what is the relationship between relaxation time and resistivity. So, use that fact. Relaxation time, that is tau, is inversely proportional to resistivity. So, based on that you can find there is only one term which varies inversely with resistivity. So, you can answer that. Okay. One more minute I am giving you. Varija Salian saying 4b is over. Only one option is given 4b, right? Okay, interesting, interesting. Yes, your logic is correct. You are thinking like topper, Varija. Interesting. So, I always say that if there is an option which just matches only one, then you don't need to look for others, but here she started with the last option and somehow it got matched. So, definitely possibly only 4b, but you have to understand the concept, because in exam same question might be asked, but they will give you. So, 4b, she is saying that 4b is the correct answer. Yes, 4b matching is correct, 4 is matching with b, this is the electrical resistivity. Okay. So, from there she figured out this must be the correct option, but in exam suppose they have given 4b here also, then how to know, how do you know that this is the correct answer? You have to be careful. So, I said relaxation time tau is inversely proportional to the resistivity rho, right. So, this is tau, tau is inversely proportional to rho. So, definitely 1 will be matched against C, right, 1 will be against C. Now, drift velocity is slightly tricky, so I am leaving it for now. Okay, drift velocity I am saying it is leaving it for now. Current density, current in terms of drift velocity is given by, current is basically given by I equals to NEA VD, right. Now, current density J is basically I by A. So, basically it will be NEVD. So, definitely as we can see current density is NEVD, area is missing here. So, that means it represents current density. So, this is current density. So, this will be 3, right. And electrical resistivity is again I have done this derivation once more, those who have not joined during that time. So, we know that J equals to sigma E, J equals to sigma E, or E by J is basically 1 by sigma. 1 by sigma is basically the resistivity, conductivity, 1 by conductivity is resistivity, right. So, 1 by conductivity is resistivity. So, definitely resistivity is number B. So, this is 4, right. So, whatever is left, that is drift velocity is matching with this. Okay. So, this is slightly tricky to remember. This is also an equation given in your book, but it does not come directly from any of the formulas. You have to do the derivations. That is why I left drift velocity for the last. So, if you face a matching question in the exam, try to see whatever matching you exactly know. First, you to try to find out, okay, what are the matching. I may not be aware of relaxation time, I may not be aware of drift velocity, but current density seems matching, electrical resistivity seems matching. For example, Varija in this case directly guessed the answer by matching 4 and B. Okay. So, first you see whatever you know directly, based on that you can find the correct answer even if you do not know the answer. So, correct answer in this case is B. So, 1C, let us check it once more, 1C, 2D, okay, then 3A and 4B. So, correct answer is option B, right. Also 3A only. Yes, 3A only. Okay, 3A only is also one option. Correct, correct. So that's what I am saying. So even if you are confused due to the given options, try to match whatever you know first. Okay, and in case that does not give you any correct answer, then you have to wait, you have to think a little bit more. Later on, leave that question. Later on, you can come back to the question anytime and solve it. But first you have to check whatever you know first. Based on that, you can directly answer the question. And this is also a good trick in KSET exam. I have seen a lot of KSET exam, this matching type of questions, they have only one correct option, because either first or second or third, they have only one correct matching. So if you know that trick, this is a very common trick. Okay, teachers also often give you the chance that if you know this correct answer, then you can definitely find the correct answer. And generally that is a easier matching, right? The easier matching, they give it a hint. So you have to identify that. Now question number 17, we have wasted some time on that question. That was a very interesting question. So I wanted to guide you for any future difficult questions like that, right? Now Kannadiga, you didn't answer the question. Now answer this question. The resistance of a wire is R ohm. If it is melted and stretched to n times its original length, the new resistance will be. So resistance was R. Now what happens? Suppose this was the resistance wire. Now it is melted and now its length is increased by n times. Okay, suppose the initial length is L, now the length is NL. Now what will be the new resistance of the wire? Okay, there is a short formula. Derivation is also there. I am not doing the derivation for this case. I will just give you the formula, sufficient for you to remember, easy formula. 17D, it is compressed. No, it is not compressed, it is stretched. Okay, if you are saying if it is compressed, yes, okay, got it. Yes, so if you expand, if you stretch the wire by n times, so maybe you have doubled it, maybe you have quadrupled it, maybe you have made the length 3 times, 4 times, whatever times you have done. So when you are increasing the length, okay, without changing the material, without changing the total material inside the wire, then definitely the new resistance will be n square times R. You have to remember that. Why it is so? Because when you are stretching it, the cross sectional area is decreasing. So cross sectional area is decreasing, that's why resistance will be increased by n square, nth square times. Similarly, if you compress it, now if you compress it to say a length of L by n, so now you have make the distance halved or 1/4 or 1/3 or 1/5. In that case, the resistance, if it is compressed, for compression, the new resistance will be R by n square. This is also a handy addition. Thank you, Varija, for reminding me. Okay, so this is a way you can solve it. Okay, it will be always n square. Okay, either multiplication or division. Multiplication in case when you are increasing the length, obviously increasing the length, resistance will increase. So resistance increasing means it will be n square, and if you compress it, then resistance will decrease and it will be again n square. N square you have to remember only. Resistance increasing means multiplier, resistance decreasing means division, right? Now 18th question. Statement 1. When a wire is not connected to a battery, then no current flows. Okay, so this is statement 1. Statement 2. In the absence of electric field, free electrons moves randomly or does not move in a particular direction. Okay, so basically it is saying that when a wire is not connected to a battery, then no current flows. Now obviously I guess most of you have guessed the answer. Shankar, option, you have only mentioned the question number. Both statements 1 and statements 2 are true, and the statement 2 is the correct explanation. Both statements 2 are correct but not explanation. Statement 1 is true, statement 2 is false, statement 1 is false, statement 2 is both are false. Okay, yes, Shankar, 18A, Shakatali 18A, Aishwarya, no, Aishwarya not 18C. Okay, so because they are moving in the random direction, the average velocity is 0. Okay, and average velocity is 0 means they are not moving in a particular direction. To have a particular direction, you need a external electric field, so that the electron starts drifting in a particular direction. So when why the term is drifting, because the random motion is still there, but still the average motion is in a particular direction. Okay, so in the absence of electric field, their motion is random, so average motion is 0. So they do not move in a particular direction. So definitely that is why the current is 0, even though there is no there are a lot of free electrons. If you touch a conductor, you don't get electrocuted, because the average motion is 0. Okay, so both statements are correct, and statement 2 is the correct explanation of statement 1. Okay, because there is no particular direction, the current will be 0, right. So you have to see if this is correct, this is wrong. Not C is not at all true, both are correct statement. Okay, Sanjana also mentioned correct. Then Varija, yes, I think she deleted her comment. Don't delete the comment, let it be there. You may be wrong, that does not matter. Okay, you can learn from your mistakes. Aman Shetty is now coming back again, 18A. Now next question. Which of the following is different from the others? Okay, volt square per ohm, ampere square into ohm, volt into ampere, joule per second square. Now if you tell me what quantity we are talking about, I will give you a very warm welcome. Okay, this is a particular quantity having different units, that is the thing. Okay, so we are talking about a particular quantity. Okay, and if you can guess that, then you will be getting a clap from me. Shankar GL 10D, no, 10 no, 19. Shankar again 10D. 19D, you are trying to say 19D, yes, I get it. So Shankar is saying 19D. So any other answer? And what quantity, Shankar, what quantity we are talking about? Please mention that. What quantity is being talked about here? Please, if you know, please answer it. If I give you the quantity, you can answer it easily. Aishwarya Hiroli says 19A. Let's see. So basically that quantity that we are talking about here is no, Aishwarya, unfortunately it is not 19A. Oh, you are saying 18A. 18A is already done. Anyway, so 19, we are talking about a quantity called power. Power is given by 3 different formulas. First formula, I say power is equal to Y. Okay, if you are fan of Arcane TV series, you know who is Y. If you are not, you know Vodafone Idea. So whatever you want, you can remember it like that. So Y is V into I. So voltage into power. So voltage is volt and I is ampere. So volt into ampere is power. Okay, again another form for power is V square by R. Okay, V square by R. So V square is volt square and divided by ohm. So it is volt square ohm inverse. So this is also a unit of power. This is also an unit of power. Ampere ohm. Let's see another formula for power. Another formula for power is I square R. I square R. I square is ampere square, resistance is ohm. So ampere square ohm, this is also representing power. So all of these 3 terms represents power. Now what is the old unit of power we learned in our first PU? Old unit of power was watt. Now all of them are same. Okay, all these quantities along with watt, they are all same, and watt was joules per second, that is joule into second inverse. Now they have given cleverly they have given joule per -2. So that is why this is the incorrect answer. Okay, if it was -1, then all 4 would have the same unit. So that is why this is an interesting question. That's why I said So, if it was -1, then all 4 there was no correct answer in that case, but unfortunately they have given this as -2. So, joule second to the power -2 is not unit of power, all other quantities are actually unit of power. So, definitely this is the odd answer, but this is too easy in my opinion, because obviously they have given all the units ampere, volt, volt ampere, and one unit they have given for mechanical chapter, that appears to be different. So, even if you can guess it, you can answer it correctly. Yes, now a lot of questions are Varija, yes Varija, all of units are power. Shankar also mentioned power, Sanjana also mentioned power. Yes, yes, correct. Shaukat Ali 19D, Sanjana V 19D, Ajay AS 19D, Pratima joined late, but okay, 19D, correct answer. 19D is correct answer. Are you enjoying the session or not? Please let me know in the comment. So, when a steady current flows through a metal conductor of non-uniform cross section, then drift velocity is. So, a steady current. So, you have to understand the question first. A steady current flows through a metal conductor of non-uniform cross section, then the drift velocity is independent of area of cross section, directly proportional to the area of cross section, inversely proportional to the area of cross section, inversely proportional to the square of the area of cross section. Very interesting question. So, basically they are saying that wire, say a wire with a non-uniform cross section. So, suppose this is the wire, current is flowing. Steady current means I is constant. Okay. So, suppose the drift velocity here is Vd1, drift velocity here is Vd2. Now, what is the relationship between Vd1 and this area A? Okay. Suppose this is the area A1, this is the area A2. It's like a Bernoulli's principle, but in current. Okay. Now, tell me the answer. Inversely proportional, directly proportional, Vd is equal to I into NAES. 20C. Yes, no worries Pratima, you can check the stream later on. We have solved a lot of interesting questions in this session. So, definitely you can check the session later on. Okay, you can make it even once the lecture is over, you can speed it up for and 2x speed and you can check it. Okay, Aman Shetty 20C, Shaukat Ali 20C. Okay, inversely proportional. So, we know that current is basically given by NEA Vd. This is a very important equation you have to remember from the chapter current electricity. This is very important. It is important for all joint entrance NEET exam. It is important for KSET exam. This is one of the most important and most asked formula. So, current is basically NEA Vd. So, Vd is basically I by NEA. Right. Now, so we can see that if the current is steady, that means I is constant. If the current is steady, I is constant, then drift velocity is inversely proportional to area. So, it is not constant, it is dependent on cross sectional area and it is inversely proportional to cross sectional area. Okay. Now, this is an interesting question. So, let us understand this question first. Consider a thin square sheet of side length equals to L. So, this is a thin square sheet. It is a sheet. Okay, this is like a sheet of paper. Okay, length is L and thickness is T. So, this is the thickness. Okay, maybe it is clear in your diagram. If it is not, it's like it's lying on a table. Okay, so you can consider this is a thickness T, length L, lying on a table. Okay, made of material of resistivity rho. So, resistivity of the material is rho. The resistance between two opposite faces shown by the shaded areas in the figure is. So, now you might say that what is the length of this side? Okay, because they are saying that what will be the resistance if you attach, say, in this side and in this side, what is the resistance between these two terminals? Now, you have to understand that this is a square sheet. Square sheet means all sides have same length, right? So, if this length is L, definitely this length will be also L. Okay. Now, they have said that what is the resistance between these two faces, okay, directly proportional to T, directly proportional to A, independent of T, independent of L. Let us see. So, we know that resistance is given by rho L by A. So, definitely resistance is directly proportional to length, okay. But what we have to consider is that we have to consider this area A. So, this, if you just see this directly proportional to A, L, then you will not be able to answer this answer correctly, okay. Pratima answered correctly, yes, independent of L, independent of L, yes, yes. Varija also answered, oh, Varija also answered, Shagufta also answered, Shankar also answered, independent of L. Now, why it is independent of L, that is very, very interesting. So, R is basically rho into L. You have seen this question somewhere because it is so fast. So, the thickness is T, length is L. So, what is the area? What is the area of this portion? Because we know that this is rho L by A. So, area is basically thickness T into length L. So, T into L is the area, right. So, if you put that area value, they will cancel each other. So, it will be rho by T. So, resistance is independent of L and inversely proportional to the thickness T. So, all of this, it is independent of L, it only depends on thickness T. So, correct answer is independent of L. If that is inversely proportional to T, that might be a correct option, but yes, 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 area is L into T. Yes, Shagufta is correct. Yes, interesting question. Now, next question, another slightly interesting question, not super interesting like the previous one, but again, identify the wrong statement from the following. So, you have to identify the wrong statement. We have not solved this kind of question so far. The drift speed acquired by free electrons per unit electric field is called mobility. The conductivity of semiconductors decreases with increase in temperature. Okay. The conductivity of conductors decreases with increase in temperature. Alloys are widely used in the construction of standard resistors. Okay. So, drift speed acquired by free electrons per unit electric field is called mobility. Aditya came back. Varija is saying 22. Someone deleted the content before I answer, before I read. Varija is saying 22B, Shagupta 22B, Aditya is saying 22C. Why 22C? Conductivity of wrong statement. You have to identify the wrong statement. So, 3 of them are correct, only 1 is wrong, right. Aishwarya came back and now saying option B. Yes. So, option B is the wrong statement. Why wrong statement? Because conductivity of semiconductors increases with increase in temperature. So, semiconductors are opposite to that of conductors. So, their conductivity increases with increase in temperature, but here they have mentioned decreases. So, this is the wrong statement. So, again, in case you have any doubt, similar questions are, this type of questions are common if you attempt KCET, if you attempt PU board as well. So, both cases you will find this type of wrong, identify the wrong statement, identify which is incorrect. So, in that case you have to, you may be, in some cases some options you may be not sure, but you know that for fact only one of them is incorrect, right. For example, if you are studying this for the first time, you might be thinking, okay, what is the relationship between drift current and mobility? I forgot. Do not worry, ignore that relationship, that is not super important, but you check all other options, and in case you find any incorrect statement, okay, that should be the answer, no matter you know this option or not. Okay. So, maybe you do not know why alloys are widely used in construction of standard resistors or not. Yes, manganese Constantine we have seen in past few questions, but maybe you are not aware that what is standard resistance, if alloys are used or not, you do not know, ignore that option, you check whatever is definitely wrong. Okay. So, if that is definitely wrong, then that means other options must be correct. So, you have to use that assumption. At 0 degree K, it is an act as insulator. Yes, semiconductors definitely they are perfect insulators at 0 Kelvin. That is the property. At higher temperature, it behaves like a conductor, and we dope it to make it behave as a conductor in our normal room temperature. We will discuss about semiconductors when it comes. That will be a very interesting discussion. Don't worry about it. Now, question number 23. A wire has a non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which of the following statement is correct? Another similar question related to drift velocity. Only thing is that here they have given you the conductor directly. So, steady current I is flowing. Again, now if you have understood the previous question, you can answer. The drift speed of electron is constant. The drift speed of electron increases while moving from A to B. So, now they have given you the question slightly different form. Drift speed of electrons increases while moving from A to B. Drift speed of electron decreases while moving from A to B. The drift speed of electron varies randomly. Shagupta 23C, Pratima 23C, Aishwarya 23C, Varija 23C, Shankar 23C. Yes, so we already learned that VD is inversely proportional to area. So, smaller the area, higher is the drift speed, higher the area, smaller is the drift speed. So, drift speed of electron decreases while moving from A to B. So, here as you can see the area is small, here the area is large. So, as the electron is moving from lower area to higher area, the drift speed is decreasing, right. So, correct answer is option C. Next question. The resistivity of metallic conductor dash with decrease in temperature. Okay. So, resistivity of metallic conductor decreases with decrease in temperature. Now, it is talking about resistivity, directly resistivity, easy question. So, resistivity of metallic conductor, only thing you have to consider is decrease in temperature. If you understand that, then you can answer. (24B) as usual very fast, yes. So, 24B is the answer. So, decrease, resistivity and temperature are directly proportional. So, if temperature decreases, resistivity will decrease. So, they are directly proportional. Okay. So, resistivity of a metallic conductor is directly proportional. So, it will decrease with decrease in temperature. If the temperature decreases, basically it becomes a better conductor, that means resistivity decreases. Who all answered? Shankar saying 24D, no, 24D is not correct answer. Okay. Shagupta is saying 24B, Pratima is also saying correct answer, decrease. Yes, direct proportional, Shankar, they are directly proportional, right. So, directly proportional means if one decreases, another one will also decrease. If one increases, other one will also increase. Okay. If you still have any doubt, ask me at the end of the lecture. Okay. 25 question number 25. Kirchhoff's junction rule is a reflection of. So, we have already seen one such question. So, Kirchhoff's junction rule, now they have changed the question name. Kirchhoff's junction rule is a reflection of conservation of momentum, conservation of current density vector, conservation of charges, conservation of energy. So, Kirchhoff's junction rule is conservation of charges. I am answering it for yourself because we have already seen. Yes. 25C, 25C, 25C. Okay. Okay, you compute relaxation time. No, not relaxation time. They are talking about temperature. Okay. So, not about relaxation time. Yes, relaxation time and resistivity, they are inversely proportional, but temperature is directly proportional. So, relaxation time was represented by tau, whereas temperature is represented by capital T. So, even though they are similar terms, but one is Latin, one is Greek, one is English. So, maybe. Okay, be careful while answering. Think a second before answering. Don't be too hasty while answering, especially in your board exam. Now another question, the value of internal resistance of an ideal cell. I already answered this question while solving one of the question. Okay, so while solving one of the question, even though the question was something else, but I answered what is an ideal cell. 26A. 26A. So I obviously it cannot have a fixed value. So option B and C is not correct. So either option A is correct or option D is correct. Okay, so value of the internal resistance of an ideal cell. Pratima 0, Aishwarya is saying A, Shagupta A, Shaukatali A, Aditya is also saying A. Yes, A. Ideal cell means everything is ideal, so no power dissipated. So basically that means internal resistance will be 0. 27. When current flows through a conductor, its temperature. Current flows through a conductor, its temperature. Now this is not an ideal condition. This is a regular condition. Okay, this is an ideal. If it is an ideal condition, Ohm's law is valid. Then temperature would have remained constant. But this is not an ideal case. This is a general case. Okay, so when current flows through a conductor, its temperature. Shankar answered correctly. Varija, it is saying about talking about a conductor. There are some material I know which can give you both results, but conductor will give you only one result. Okay. (27A). Yes, it will always increase. When current flows through a conductor, it gives the Joule's law of heating. If you remember, current is basically the heat produced in the circuit is given by I square RT. You remember, you have studied in your class 10th. Okay, Joule's law of heating. Current flows through a conductor, gives rise to heating effect of electric current. So this is called heating effect of electric current. So whenever current flows through a conductor, it always produces heat. So its temperature will always increase. Okay, there are certain materials, specially designed materials, which show opposite to that. If you send current through it, its temperature decreases. That is a very special material. Okay, for normal conductor, temperature will always increase. Okay, that is why it is called Joule's law of heating. Okay, if you remember it, you can answer this question. Clear? Yes, Varija, yes. Right. For normal conductor, Joule's law of heating says that it will always increase. Now SI unit of current density, this question was asked in 2024 PU board exam, and unfortunately many students actually answered it incorrectly. Shokatali 27A, yes, 27A was correct. Now Pratima corrected her answer, 27A. Shokatali, no, 27C is not correct answer. Shankar also 27C is not answer. 27 would have been 27A. Okay, Shokatali and Varija. Now Shokatali and Shankar. 28B, Varija, Shokatali, Shagufta, Varija. J equals to I by. Yes, current density is basically current divided by area. Current density, so obviously current will be there. Current divided by area, so it will be ampere per meter square. Now unfortunately symbol for area and unit for ampere are same, but here this A is area and here this A is ampere. Okay, so ampere per meter square. So correct answer is ampere per meter square. Many students who are not very thinking their mind, because when you are writing your final board exam, a lot of things will change. Okay, you will be a lot of confused state, you will be in some different state of mind. Even though you know the answer, your anxiety will make the answers difficult. So student thought, okay, density means definitely meter cube. So many students answered it ampere per meter cube. Okay, because normal mass density is meter cube, right? So they answered it wrong with meter cube, but for current density it is ampere per meter square. Okay, clear? Now 29, magnitude of drift velocity per unit electric field is. So magnitude of drift velocity per unit electric field. Mobility, drift velocity, relaxation time, resistivity. Interesting question, please. Shagupta, yes. So that is the definition of mobility. We have seen it in one of the previous question, where there was an option, you have to choose the correct option. Remember, I think question number 22 or 23, where few options are given and there was only one incorrect option. So one of the option was drift velocity per unit electric field is mobility. So this is basically the definition of mobility. Mobility is denoted by symbol mu. So this is the mobility. Okay, yes, Varija, yes, Varija, Pratima also answered it correctly. TR Gamer joined late. Shagupta, Shaukat Ali, Pratima, it's mobility. Yes, it's mobility. Yes. Next question. I think we have up to question number 35, right? Yes. We have 35 questions, so 6 more questions including this one. So let's complete this quickly. Which of the following characteristics? Now this chapter is very important question. All of the questions that we discussed, many of them are actually important for KSET and easier level of NEET exam if you are preparing for them, right? This is the one of the most important question for KSET, especially if you are preparing for KSET. This chapter is a must. Which of the following characteristics of electron determines the current in a conductor? Thermal velocity alone, drift velocity alone, both thermal and drift velocity, none of the above. Another very interesting question. What is just saying 30C, Aishwarya 30B, TR Gamer 30B, Shaukat Ali 30C, Pratima 30C. So current, what we discussed, if there is no electric field, what is the average velocity of electron? If there is no electric current, average velocity of electron was 0. Now what is that velocity? That velocity is thermal velocity. Okay. So now we know that the total velocity of electron will definitely be drift velocity plus thermal velocity. Yes, this is correct. Thermal velocity plus drift velocity will be the total velocity. Now if you take the average, velocity, okay, if you take the average of all the electrons, okay, and you try to find the average velocity, then you will get that it is only sum of drift velocity by n, because sum of thermal velocity is basically, this term is 0. So average electron velocity is basically average drift velocity, right? It does not depend on thermal velocity. Thermal velocity, if you take the average, it will cancel each other. Okay. So only depends on drift velocity. So current in the circuit depends on only on drift velocity. Instantaneous velocity of electron depends on both drift velocity as well as thermal velocity, but on a long term, when you are taking the average velocity, the thermal term will be cancelling. Thermal term will cancel each other. Okay. So when you are considering the electron velocity of the electron, that means only the average drift velocity. That is why when we consider the expression for current, we only see NEA VD. Is there any thermal velocity term present here? Is there any thermal velocity term present here? There is no thermal velocity term present here. Yes, it might depends on relaxation time, but unfortunately it is independent of thermal velocity. Current depends only on drift velocity. Okay. N is number density, E is the number of electron charge, A is area. So does not depend on thermal velocity. If you have that misconception clear in your head, I remember in one of the very old videos, I actually gave this answer, both thermal velocity and drift velocity, in one of my old KSET video, but that was wrong. I corrected that in my upcoming subsequent videos. So drift velocity alone, it depends only on drift velocity. So if you take the average of the velocity, thermal velocity actually cancel each other. Only drift velocity that determines the current in the conductor, right. 31st question number 31. A piece of metal is to be converted into a rod of highest resistance. Very interesting. A piece of metal is to be converted into a rod of highest resistance. Which of the following is the best choice for length L and diameter D? Okay, so you have a wire. Now you want to convert it into a resistance, into another wire, okay, having higher resistance, not highest resistance, that means higher resistance. Okay, what you want to do to increase the resistance? 31A, L by 2, D by 2, 4R, what is 4R? 4R, no, that is what I am saying, 4R, not 4R, not 4R, it can be, no, yes, correct answer is obviously option D. So when you want to make it, you want to convert it into highest resistance, then only thing you want to do is to increase its length, okay, increase its length and decrease the surface area. You want to increase the length, you want to decrease the surface area. Resistance is basically rho L by A. So how can you increase the resistance? To increase the resistance, you want to increase the length and you want to decrease the surface area. So to increase the length and decrease the surface area, correct option is this. Okay, and in this case, if you multiply these two terms, you will also observe that the volume remains constant. Volume is basically L into D. Okay, if you choose this option, okay, your volume is decreasing, that means you are losing out a material. So definitely this is not possible. So only possible was this one or this one, because volume has to remain constant, right. But out of this you are decreasing the length, increasing the diameter, that means resistance is decreasing. So if you want to convert it into highest resistance, that means you have to increase length as much as possible and decrease the diameter as much as possible. Okay. So from the given option, from the given choices of option, this is the correct answer. Yes, 8R will be the correct answer. Okay. Okay, 31D. Next question. A steady current I is flowing through a conductor of uniform cross section. Okay, steady current I is flowing through a conductor of uniform cross section. I think this question is somewhat incomplete. Conservation of momentum, conservation of current density vector, conservation of charges, conservation of energy. I think this question is important. The options are incorrect. Okay. Let me move on to the next question. The wire of length L is stretched to double its length. The resistance of the wire gets doubled, the resistance of the wire gets quadrupled, resistivity of the wire gets doubled, resistivity of the wire gets quadrupled. Easy question. Without wasting time, Aishwarya also answered the Aishwarya 32 question was, I think, not making any sense. Either question statement is not complete or the option is not complete. Okay, so that's why I skipped that question. Okay, that question is not making proper sense. Which one is the correct option or what is the relationship? That's why I skipped it. Okay. Varija, Aditya is saying 33A. Aditya, you are late. That's why you are thinking completely different way. So we already said that resistance is basically N square R, right? Resistance is N square R. We have already solved it. So length is stretched double. Length is stretched double means it will be 2 square into R, right? So 2 square is 4 into R. So the resistance will be quadrupled. Quadruple means 4 times. Quadru means 4, right? Quad means 4. So, quadrupled means 4 times. So, definitely resistance will be quadrupled. Now, question number 34, Ohm's law is applicable to. We have seen one question, Ohm's law is not applicable to, here it is applicable to. Aditya 33 B was correct answer. Aishwarya, Pratima, Varija, TC Gamer, Shaukat Ali, they have all answered it correctly. Okay, Aditya, you have to be little bit thoughtful while answering such questions. Now, this is an interesting question, easy question, but please answer it. I will wait for a minute. I still have a lot of time. Till 7:30 used to be my class, but I think I will close it in 3-4 minutes. So, I am just taking some time. Yes, 32, maybe that may be the question. Okay, yes, the net current in a current carrying conductor, the net charge is 0. Yes, somehow I said something was incomplete about that question. 34D, Deepa is at last she came and answered. Shaukat Ali 34D, yes, conductor. So, all of them, diode, transistor, electrolyte, they are all electronic devices and they do not obey Ohm's law. Okay, transistor is a device which is used inside your computer. Okay, previously there was only a single transistor. Now we are using integrated circuits. There are lot of transistors and diodes are there. Electrolyte also, in electrolyte also, electrolysis you have studied in chemistry, right? There also Ohm's law is not valid. The resistance is not directly proportional to current, voltage, right? Voltage and current are not directly proportional. So, electrolyte also it is not valid. Only in case of conductor Ohm's law is valid. Last question is this is a case set special question. This question will never come in your board exam, that is my guarantee, but I feel okay, it's too easy. Let me give you something to think about. Okay, so this is a case set special question, maybe easier level of NEET exam as well, but very interesting. Masses of 3 wires of copper are in the ratio 1:3:5 and their lengths are in the ratio 5:3:1. The ratio of their electrical resistances are. Okay, so masses, remember that masses M1:M2 M3 equals to, even I forgot the answer. I solved it a long time back, but I forgot the answer. So, masses are in the ratio M1:M2 M3 and their lengths are in the ratio L1:L2 L3 equals to 5:3:1. Okay, this is given and they have asked you what is the ratio of their resistances. Okay, so I solved it before. Okay, Varija is saying she solved it before. So, 125:15:1, and now because Varija said I have solved it, so maybe you have solved. Aishwarya answered it faster anyway, 35C. So, Shaukat Ali is also saying 35C, Shankar 35C, Deepa Chautpar is also saying 35C. Let us see the answer. The thing is that we know that mass is we have to first establish a relationship between resistance and mass. Okay, so far we have ignored the mass term, but we know that resistance is basically given by rho L by A. Okay, rho L by A. Now, what is the relationship between resistance and mass? So, we know that mass is basically density of the material, say D, density of the material times its volume, right? Density of a material in normally is constant, right? So, density is constant. Now, density also we represent using rho, but because rho is already present here, I am avoiding the term rho here. So, density is represented by D, which is a constant for all the materials. Now, for example, for copper density is constant, for iron density is constant, but it is different from that of copper. Now here we are considering only copper wires, right. So density for all types of copper wires will be constant. So D we have one constant. Now what is volume? Volume is basically D is equal to area into length, right. So volume is area into length. So we can find area from this equation. So area is basically mass divided by density into length, right. Now we take this and we put it in this equation. If we put it in this equation, we get rho L by M by dl. Okay. Now dl will go up, so rho dl square by m. Okay. So rho dl square by m. So resistance is basically proportional to L square by m. So what we have done, we have replaced this area with mass, okay, and we found out that resistance is proportional to L square by m. So definitely R1 is to R2 is to R3 will be L1 square by M1 is to L2 square by M2 is to L3 square by M3. Other terms are constant, so they will cancel. So L1 is given by 5. So 5 square is 25 divided by M1, M1 is 1 is to L2 is 3. So 3 square is 9 divided by M2, M2 is 3 is to L3. L3 is 1, so 1 square is 1 and M3 is 5, so it will be 5, right. So this will cancel, this will get 3. So we get 25 is to 3 is to 1 by 5. Now we cannot leave this 1 by 5, so we have to multiply all the terms with 5. So 125 is to 15 is to 1. So correct answer is option C. Yes, wire resistance 4 ohm is used to wind yes, I will Yuvraj, I will try to give you the formula sheet for all the chapters. We are currently in the preparation of all the formula sheets. We will give you all the important formulas from all the chapters very soon, okay. Maybe in 1 week or 2 weeks times we will give you. It is taking some time. It is not easy because we all are busy in the regular classes. We have another channel as well. We have a foundation channel for class 10th. So every foundation class 10th exam is also coming up very soon for CBSE. That's why we are a lot of time is taking up. So we are in the process. We will prepare a formula sheet for you. So let me see the question. Wait, Varija. A wire of resistance 4 ohm is used to wind a coil of radius 7 centimeter. The wire has a diameter 1.4 millimeter and the specific resistance of the material is 2 into 10 to the power of minus 7 ohm meter. The number of turns diode is not deleted, Aishwarya. Deleted is logic gate. Logic gate is deleted. Diode is not deleted. Okay, diode is not deleted. Logic gate is deleted. Transistor was deleted long back. Okay, communication system is deleted, but diode is not deleted. Kannadiga, yes, your lab marks will affect your final exam because they take 50% of your total marks that you get in your board exam, right? So 70 plus 30, okay, so total is 100. So they will consider 50% of that. They will consider 50% of that. So they will, yes, it will affect. Let me, what is the difference between 0 and infinity, sir? So 0 is basically where we start, everything starts, that is 0. Infinity is mathematical definition is more than whatever highest thing that we can consider. Higher than the highest number we can consider, okay. And the definition is you can say if you divide anything with 0, you get a thing called infinity. Okay, there is a limited definition of infinity as well, but most important thing you have to remember that infinity is basically 1 by 0. Similarly, 1 by infinity is 0. Okay, but infinity is still considered as a number. There are something which is called undefined, that is not that cannot be defined, that is something else. Okay, Zener diode is deleted. Yes, Zener diode, only the name Zener diode is there, only the basic use of Zener diode is there. No numerical problems related to Zener diode is not there in KSET, it is there in JEE. If you are appearing for JEE exam, I think it is going on, maybe 1 more day or 2 more days schedule is still there. So, if you are appearing for JEE, it is there, but for KSET, for PU board, Zener diode is deleted. Only it is there as a application of diode, but just the name. Other than that, nothing else is there. Varija, give me 2 minutes. I have some time. I can solve your question. A wire of resistance 4 ohms. The initial resistance of the wire. A wire of resistance 4 ohm. Okay. Is used to wind a coil of radius for 7 centimeters. So, now it is a coil of radius 7 centimeter. Okay. The diameter is 1.44 millimeter. So, diameter of the coil is 1.4 millimeter. Okay. And the specific resistance is 2 into easy question 2 into 10 to the power of minus 7. Okay, this is the rho. Okay, so rho is given, diameter is given. I am not going to solve everything, easy question. So, diameter is given means D is given, right, 1.4 millimeter. So, what is radius? Radius is 0.7 millimeter, that is 0.7 into 10 to the power of minus 3 meters. So, radius is given, you can calculate the area, pi r square, that is 22 divided by 7 into 0.7 into 10 to the power of minus 3. So, you can cancel, you will get 22 into 10 to the power of minus 4 meter square, that is the area. So, area is also calculated. Now, what you have to do, you have to find the length. Suppose the number of turn is n, okay, what is the length of one turn? What is the length of one turn? Length of one turn is, for one turn the length is 2 pi into this small radius r. Okay, here this is the small radius, 2 pi r is the length of one turn. So, the length is 2 pi, that is 22 by 7 into 7 centimeter. Centimeter means you again have to convert it into meters. 7 cancelled, 44 into 10 to the power of minus 2. Meter is the length of one turn. So, number of turns suppose is n. So, total length will be n into this distance, that is 44 into 10 to the power of minus 2. So, this is the length. Now, we know that resistance is rho L by A. Okay. Resistance is given 4 ohm, rho is given this value 2 into 10 to the power of minus 7, L is given by this value 44 n into 10 to the power of minus 2, and area we have already calculated, that is 22 into 10 to the power of minus 4. So, you have to cancel it to, okay, this will be 10 to the power of minus 3. Okay. So, 4 n into 10 to the power of minus 5 equals to 4, right. So, 4 cancels, you have only 1. So, n is basically 10 to the power of 5. So, number of turn is 10 to the power of 5. Okay. Now, let me see Varija, no, meter bridge we will not come. Okay. Meter bridge will not come. Meter bridge was there in your syllabus as a part of application, but the application part of meter bridge is deleted. Using meter bridge you can use to calculate the unknown resistance. There was also one more part where you can measure the temperature using meter bridge as well, but those experiments are deleted. So, meter bridge will definitely not come as an application of Wheatstone bridge. If they ask you a question from Wheatstone bridge, they will either ask directly from Wheatstone bridge, or they will give you a circuit diagram and they might ask you what is the unknown resistance, like that. Meter bridge will not come as an application. Which topic is important in semiconductor? Aishwarya, what topic for K-set? Okay. Now, that is very interesting that there is only one formula is still there, that is the number density of intrinsic semiconductor versus number density of extrinsic semiconductor. I have done that in my semiconductor chapter lecture. You can check that out. It is in the 60 out of 60 in K-set series. Also, soon we will be doing one more series, one shot videos that will be launched very soon. Also, there is one more big surprise coming for all of you on 26th of January, that is Sunday. I forgot to add that slide. So, there is a very big surprise coming for all of you on 26th of January. Don't forget to stay tuned to our channel at 6 p.m. evening. There will be a big announcement for all of you. Don't miss out on that update. Okay. Varija is saying in conductor have negative is conductor have a negative resistance, because in some non-ohmic devices slope is negative. Yes, some non-ohmic device have negative resistance. That's why I said you asked about one question that whether conductivity will increase or decrease. So, there are some non-ohmic devices, they have negative resistance, but conductors do not have negative resistance. Conductors always have positive resistance even at absolute 0. Okay, even at absolute 0, that is superconductor, even they become superconductor, their effective resistance becomes 0. There are some conductors whose effective resistance becomes 0. So, that is why they are called superconductor, but other than that resistance cannot be negative for most of the cases, except some certain semiconductor devices. Within some ranges they have negative resistance. Some formulas that you said in your today's class were not there in the NCERT. So, can you give the formula sheet, sir? Ni square is equal to Ne Nh. I didn't get you, Varija, but yes, Shaukat Ali, all the formulas are actually from NCERT, but you have to read it in detail. Okay. So, there are some derivations they have done in the, especially for the relationship between mobility, relationship between relaxation time. It is there in the NCERT. I have missed in my decode NCERT part one important concept I overlooked, but yes, that was there in your NCERT. Nothing is out of the NCERT. I can show you the screenshot if you want in our community post, all the formulas that is there in from NCERT. But yes, we will give you a formula sheet to prepare easily, but please wait for some days. Okay. Because the person who is responsible for all the typings and all, she is busy right now, because we are all giving a lot of work to her. So, once she is free, we will definitely type out the equations. Okay. So, for that, okay, and I am personally is not have enough time to even I have recorded a lot of classes today. This is my 4th lecture. I have recorded a 2-hour lecture, then one 40-minute lecture, then again another 15-minute lecture, and this is the live class I am taking. So, almost more than 5 hours I am spending on lectures. I have to prepare the class PPTs as well. So, definitely I do not have the time to type all the equations for myself, but we have that in our mind for a long time. So, as soon as we are getting little bit free, we will give you the formula sheet. Can we obtain superconductor from semiconductor by increasing the temperature very high? No. technically it is not possible because at very high temperature the semiconductor will melt. If you cross their melting temperature, okay, they will melt. So you will not be able to get the semiconductor out of that. Also remember that there is a limit up to which you can increase the conductivity of a semiconductor with temperature. Okay. So resistivity, there are and it is not super simple. There are two components of resistivity, one increases with temperature, one decreases with temperature. For semiconductor, up to some level the component which decreases with temperature actually dominates. After that the component which increases with temperature dominates. So they balance it each other. So you cannot increase the conductivity beyond certain limit when you increasing the temperature, and if you increase the temperature too high, it will melt and it will no longer be useful. Okay, very interesting. If you are interested in electronics devices, you can definitely try to study electronics in engineering subject. Very interesting. A lot of things you will do, and in future try take up research on this part. Okay, a lot of scopes are there. People are doing a lot of research in this, and a lot of new things are coming up every day. Okay, so for example, this mobile phone, starting from mobile phone, starting from computer, laptop, etc. That is the research of electronics. So if you are interested, definitely you can study. Yes. Yes, next chapter, moving charges. We are going chapter wise, book wise, because all the chapters are equally important. We are getting 15 questions from 14 chapters, so definitely you are going to get at least 1 to 2 MCQ from all the chapters. So no chapter is less important when we are discussing MCQs. So we will be following the chapter sequence in your textbook: moving charges and magnetism, magnetism and matter, and so on, electromagnetic induction, AC, and then electromagnetic waves. So we will follow the sequence. Okay, thank you. Dhanashri, yes, we will do one shot video on every chapter for cassette. Don't worry, that will be that is already in our agenda. We are already started working on that. So maybe you are thinking that sir is teaching us MCQ, but in our background a lot of work is going on all the other things that is going to come. And don't forget to join day after tomorrow, Sunday, for a very special live session. Okay, and I am closing this session. It is already 15 minutes over of my allocated time. So thank you. I will be closing this lecture, and see you soon. See you on Monday. Okay, Monday will be my next chapter, moving charges on magnetism. Monday I will be back with the live, so don't miss out on Monday's